Okay, so here's a brief introduction on how to graph exponential functions, and then we'll also graph a logarithmic function. So if we do something like, write it down here, f of x equals 2 to the x. Okay, now the book, in my opinion, doesn't do a particularly good job explaining how they got the graphs. So let's keep in mind that this f of x can also be thought of as y. Okay, so you can think of this as y equals 2 to the x. Okay, and then to graph this function, you're going to plug in values for x and find your points for y on the graph. So let's say that x is 0, and then y is going to equal 2 to the 0 power. Okay? And 2 to the 0 power, anything to the 0 power for that matter, is 1. So one of your points on the graph is going to be at x equals 0, y equals 1. Okay? And I am not going to have a whole lot of screen space to write on here, so let me erase this and do the next point. Okay? So now I'm going to do at x equals 1. So I've got y equals 2 to the first, which is 2, right? So when x equals 1, y equals 2. And if I do y equals 2 to the second, so x is going to equal 2 here, y is equal to 2 squared, which is 4. So 3 points on my graph are at 0, 1, 1, 2, and 2, 4. So my x is 0, my y is 1, so there's a point right here. Whoop, there shouldn't be a point. There's not a point at the origin. I accidentally put the pen down, so ignore this. That is not a point. Ugh, I'm making it worse. Okay, hold on. Let me erase it. Now I've erased everything. Okay, whee! Let's do this again. All right, so there's a point at 0, 1, right here. There is also a point at 1, 2, right here. There's also a point at 2, 4. So over 2 on the x-axis, up 4 on the y-axis. Now those almost look linear. So we may want to do one more just to make sure that we see the real trend of what's going on. And we've run out of room on the bottom, so let's do it on top. I'm going to do y equals 2 to the third. So in this case, x is going to equal 3. So x is 3. And y is equal to 2 cubed, which is 8. So if we go over 3 and up 8, now you can kind of see more clearly the curve of what's going on. Now, the graph does not just stop here at this point on the y-axis where it crosses. So to illustrate that, what's kind of going on here, I mean, you can see it in the book, but how these functions perform. But let me actually compute one for you so you can see what's going on. So let's erase this stuff down here. And let's find out what happens when x is equal to -1. So if I do y equals 2 to the -1, well, if you put that into your calculator, or do it by hand, remember in negative exponents, take the base that it's attached to and move it to the denominator, so this becomes 1 over 2 to the 1, which is 1/2. So when x equals -1, y equals 1/2. And my pen is not exactly drawing where I think it's supposed to. Anyway, so that's a little off, but it should be right about there. So as you can kind of see what's going on, and if you continued out in this direction on the x-axis, you'd see that for increasingly negative numbers that you put in for x, your answer over here for y becomes smaller and smaller, but it never actually becomes 0. It becomes a smaller and smaller fraction. So the graph is actually getting really, really close to this axis It never quite hits, and then it curves upward like that. And that's what's called an exponential function. Okay, I'm seeing, I was going to do a logarithmic function, but I'm seeing that 10-2 just covered exponential functions. So, graphing logarithmic functions can be kind of tricky, so I guess I'm kind of relieved now looking at it that there isn't actually any graphing of that in this section. If you want to see how it works, however, I can kind of give you a brief, like a very straightforward example where y, oops, using the wrong tool. Hang on, let me get my pen. Okay, so I'm going to write it up on top here. If we had something like y equals log, there should be an O, log of x. Okay, if there's no base written here, it's assuming that you're working in base 10, and you can do it on your calculator. And, oh, I don't have a calculator handy. Okay, let's see if I can find. Okay, so if you put into your calculator, and don't try to change any bases. I'm not sure if your calculators would let you do it anyway. If you just type in log of 1 into your calculator, you would get 0. So, if this is the formula that I'm using here, then I've plugged in 1 for x, and I got 0 for y. So, when x equals 1, y equals 0, so there's going to be a point right here. Again, my pen's not drawing where I think it's supposed to. Anyway, and then if we continue on in that vein, if I do log of 2 in my calculator, so now x is 2, and y would be, actually when you work with the logs, you'll be getting a bunch of decimal answers. So log of 2 is actually 0.3001 approximately. So I'm going to put that on the calculator at the graph. So at 2, it's going to be roughly right there. And then do it again for if x equals 3, y is about 0.477. Again, you'd have to put these in the calculator to figure out what they are. So this, if you go over 3, that's at about 1/2, so it's going to be about right here. Oh, it's a little too high. But anyway, if you were to calculate more points and work this trend out, and if you were to look at some values for x between 0 and 1, so fractions between 0 and 1, you would see that the values start to become negative. So what this graph ends up doing is that it hugs the y-axis and comes out along and kind of curves off like that. It's actually a mirror image across this imaginary dotted line that runs through the origin of the exponential function. So if you remember, our exponential function looked kind of something like this. So depending on what your bases and exponents are, they look very similar, just reflected across this imaginary diagonal line that runs through the origin like this. I hope this clears things up. Again, I wasn't intending for you guys to have to graph these things, so if this is a little confusing, don't worry about it. You are going to, if you have to take College Algebra 140, you will see it there in more detail. But again, this was just to get a general grasp on what the function is and how they work. I wasn't expecting you guys to graph these at all. So let me know if you have any other questions. I'll be happy to try to answer them for you.